Hello, my name is Peter Zhu, and in this tutorial we will quickly go over the basics of setting up the microfluidics device. This is an overhead view of the chip. The 5 inputs and 2 outputs are circled in red, and the 26 control valve openings are circled in blue. The chip is bound to a cover slip base that measures 60 mm by 24 mm. Each control valve is connected to a solenoid valve by control lines, which are Tygon tubes filled with water. Input reservoirs are small vials that hold the input medium and are connected to their respective input openings by tubing. Setting up the chip requires connecting all 26 control lines and input reservoirs. This is a schematic of the chip in the same orientation as you saw in the previous slide. The control valves are labeled 1 through 26, and the input and outputs are labeled in A through E and out A and out B. These are the control lines, clustered in groups of 8 and connected in the middle by a connection block made of PDMS. One side is to be filled with water and inserted into the chip, while the other side is connected with a pressurized solenoid. Notice each of the lines are numbered and one side of the connection block is darkened. The darkened side is the side with the lowest count in that group. In this case, line 1 is the first count, starting from the darkened side, and then followed by line 2, line 3, etc. Remove these control lines right above the connection block. Make sure the solenoids are open and therefore the valves are pressurized at 15 to 17 psi during this entire process. This is to minimize the air bubbles that could enter the chip. This is a single control line removed. The end with a small blunted cannula connects with the chip at each of the openings you saw earlier. Fill this line with water by injecting it with a syringe in the other end. Do not remove the syringe. Without removing the syringe, insert the blunted cannula into its respective control valve opening. These openings are labeled in the schematic diagram you saw earlier. Now remove the syringe and connect that end with its corresponding place in the connection block. In this case, control line 1 connects with the cannula closest to the darkened side, followed by control line 2, etc. Repeat these steps for all 26 control lines. Again, make sure that the solenoid valves are open so that the control valves are pressurized as soon as they are connected. Ensure the pressure is between 15 and 17 psi. This is what a finalized setup chip looks like. Notice all the control lines are inserted into their respective openings. We will now go on to constructing the input reservoirs. These are vials that hold input media such as cells, growth media, lysis buffer, water, and etc. Constructing an input reservoir requires a vial, cap, septa, and Tygon tubing, with a pointed cannula at one end and a blunted cannula at the other. The blunted end connects with the chip while the pointed end punctures the septa and dips into the vial. Place the septa inside the cap and push the pointed cannula through the bottom of the vial. Ensure that the end of the cannula is below the surface of the media. Next, puncture the septa with a pressure syringe that is pressurized to between 5 and 10 psi. Make sure the end of the syringe does not touch the surface of the media. Now connect the blunted end with an input opening inside the chip. You are done with setting up the chip. Open and run LabVIEW script to toggle the control valves. We will briefly go over using Micromanager, an open source software designed for a variety of cameras. The specific camera we use is Roper Scientific and the PV-Cam driver. The driver should already be installed, but in the event you must reinstall the driver, make sure to install an older version. This is because current versions are incompatible with our old camera. Open up Micromanager from the Start menu. A pop-up screen will show prompting you for a configuration file specific to the camera you're using. The configuration file is found on the desktop, and clicking OK will suffice here. You are brought to the main menu of the Micromanager, as you see on the left. Notice you have the option of Snap, Live, and Multi-Acquisition. Ensure the exposure is set to 1 millisecond and binning set to 2. Without doing anything else, Snap and Multi-Acquisition will work fine, but Live will bring up an oversaturated image. Before the live feature may work properly, open up the property browser under the Tools menu. Change the setting under P mode to the first setting, alternate frame transfer parallel clocking. Clicking OK, and everything should work fine. The most useful aspect of Micromanager is the multi-acquisition feature, which allows you to take multiple images at a set frequency. Clicking the button will bring up a new menu. Everything is quite self-explanatory. Specify the number of images and the frequency of the image you wish to take in the top left. Specify where you wish to save the images and the prefix to the image names on the bottom. Clicking Acquire, and the camera will take the images as specified. This concludes our tutorial. If you have any questions, feel free to contact me at the contact information below. Thank you for watching.